Hi students, and welcome to Chapter 6, Part 1, Human Population Dynamics. So in Part 1, we're going to be looking at how they work. In Part 2, we're going to be looking at some case studies of particular countries. So if you look at world population over time, you can see that we've been exponentially growing, and there was a point where we really started exploding in our population, starting about 124 million years ago. And each one of these numbers here represents the amount of time it took for us to add each billion people to the planet. And one thing you should notice on here is that in the most recent decades, the time it took to add the next billion people has been staying about steady, which is actually a sign that shows that our growth is about to slow down or is slowing down. And if we look at when we're expected to hit 8 billion people on the planet, we're looking at 13 years instead of 12. So again, it looks like our human population growth on planet Earth, the rate of growth is starting to slow down. So where are all these people? Asia takes up the bulk of the people on the planet, and that's because the two most populous nations on the planet are China and India. Africa's share of people on the planet has been growing and is expected to keep growing over time, versus Europe's share is starting to shrink and is expected to continue shrinking over time. So the 5 most populous nations, and if you notice, there's 6 on the list here because things have changed just since last year. In 2020, China is still the most populous nation on planet Earth, although India is about to overtake China within the next decade or so and become the most populous nation on the planet. And we'll be looking at both those nations in our case study. The United States is at 331 million. And we've been in 3rd place for a long time, although we will actually be dropping out of that probably within the next 50 years. Indonesia 275, and this is the change that happened just since last year, in that Pakistan and Brazil had about the same number of people last year. This year, Pakistan has overtaken Brazil and is now in 5th place, leaving Brazil in 6th. So I love data and I love maps. And if you put the two together, you get some really cool looking things. So this is a cartogram, and what it shows is if you represented people as land area, this would be the relative sizes of all the nations on Earth. So you can see the outsized portion that China and India get. The United States is really a distant third to those 2 nations. And you can see other nations, and the one that I haven't talked about yet, but is looking at overtaking the United States over the next few decades, is Nigeria, is really rapidly growing. So our population density in 2016, again, the darker the colors, the more densely populated areas are. So the most dense nations on the Earth are Macau, Monaco, Singapore, Hong Kong, and Gibraltar. And the least dense, Greenland, probably for obvious reasons, Mongolia, Namibia, and Australia, and Iceland. Australia, by the way, is about the same size as the United States, but just has a fraction of the people that the United States has. So this is another, and we're going to look at this little video in class, not in this lecture, but this just shows another picture of population density. And I've shown you this map before to demonstrate that the humans we have clumped dispersion. We are not randomly distributed over the planet Earth. So birth and death rates, they're given as a rate out of per 1,000 people, which seems weird, like we do most things out of 100, but birth and death rates, they're reported as the number of births out of 1,000 and the death rate, the number of deaths out of 1,000 people. And this is a map that shows the highest birth rates on the planet to the lowest in the darkest blues. And you can see that Africa in general tends to have the highest birth rates, and that Europe tends to have the lowest birth rates, although there's some other standouts like Japan also has very low birth rates. So the other thing you need to realize, and this is going to come into play with the activity that you have been working on in class, is that getting good data for some areas can be very hard. So if you look at completeness of birth registrations in the upper picture, there's a lot of countries we don't have good data for, and the same thing for death reporting. So as we look at some of these numbers, realize that we have to make some assumptions about some of the data because we don't have complete data for certain parts of Earth. So as far as by region, again, Asia, because it has the most people, is going to have the outsized portion of births and deaths. But if you look at the difference here in Africa, which is rapidly growing, it has more of a proportion of births than it does for deaths right now. So when you're calculating population change, it's not just about births and deaths, but it's also about immigration and emigration. So immigration is people coming into a country, emigration is people going out of a country. And you hit 0 population growth when your births plus immigration equals your deaths plus emigration. And then you would have a stable population or 0 population growth. let's do a little example. So if you have a country that has 12 births per 12 births per 1,000 and then a death rate of 9 per 1,000 in the same year, what is its growth rate? We're not going to be looking at immigration and emigration in this example. What is it as a percent? So remember, the birth and death rate is out of 1,000. So you have a difference there of 3 per 1,000. So that would be a 0.3 out of 100. So it would have a 0.3% change in population. So again, looking at nations around the world, the birth rates tend to be higher in developing nations, and we'll go into some of the reasons why. For your developed nations, they used to have high birth rates, but they have come down. So again, if you look around the world, you can see a lot of countries kind of in the medium category, but the two standouts are the continent of Africa for having fairly high birth rates and the continent of Europe for having fairly low birth rates. So, and this is a different map or a different graph just showing you as far as the time it took to double the population. Doubling time is an important concept. Remember, you calculate it by taking 70 divided by the percent growth rate. And you can see that it really dropped and dropped rapidly up to about the year 2000. And this is yet another sign that our population growth rate as a planet is starting to slow down and that the time it's taking to double is going up, which means our growth rate must be going down. So fertility, the fertility rates, there's different things to look at. There's replacement fertility, which is the number of children a couple must have to replace themselves. So it's going to be different for different parts of the world. In developed nations, it's about 2.1. There will always be some infant mortality. In an ideal world, no infants would ever die, and it would be 2.0 exactly. But there's always some infant mortality rate. It's going to be low in developed nations that have good health care. It's going to be higher in developing nations, and again, due to higher infant mortality because of poor health care. If you look at total fertility rate, the TFR, that's the average number of children a woman will have in her childbearing years. In 2015, the global average was about 2.36. Developed nations, it's dropped below replacement level at 1.6. Developing nations is higher, and our least developed nations around 4. The little chart over on the right is kind of interesting. If you look in the 1950s, it was globally like almost 5 children per woman, down to the most recent 5 years that they have on record, it's down to 2.36. So fertility rates, total fertility rates have really dropped over the last 60 years or so. This is it, the map by as of 2018. And if you look at the highest countries, most of them are in Africa, not all, but most. And then the lowest, Cyprus, 1.0, that's a really low fertility rate. And so if we look at these things through time, 33 countries have had declining populations between 2010 and 2017. 91 nations have a total fertility below replacement. 104 have a total fertility above replacement. So what is this looking like as far as our global population? What kinds of things, first of all, bring down those fertility rates? So there's a lot of factors, and I think you have a slide on your notes that has a lot of blanks to fill in for this. So more education, more affluence. The wealthier nation and the people tend to be, the fewer children they tend to have. And part of that is if you're going to lots of advanced schooling, you're probably delaying childbirth. So increased educational employment opportunities for women. They find in particular that it's the educational and employment opportunities for women that has the largest effect on decreasing fertility rates. Greater availability of private and public pensions. If you are relying on your children to support you in your old age, then you're probably going to have more of them. But if you have a good retirement plan, you don't feel the need to have as many children. And then child labor, of course, if we don't need it, then we won't need to have children to provide it. All right, this is just speaking about the educational attainment by for women, and how do we come up with these ideas about what decreases fertility rates? Well, we can look at data for that. So this is children per woman on the y-axis and number of years of schooling of women in reproductive age on the x-axis. And you can see that definitely they tend to, the less schooling you have, the more children you tend to have, and the more schooling you have, the fewer children you tend to have. So we have good data behind all of our assertions. So more factors that can decrease your fertility rates. More urbanization, people living in cities, Higher average age of marriage, that one's pretty self-explanatory. Increased cost of raising and educating children. This is going to be a factor for me personally. I would not have been able to afford more than one. Decreased infant mortality. This one can be kind of counterintuitive. But if there's a high infant mortality rate, if there's a decent chance that your children might die as infants, there is a psychology behind that then you're going to have more of them because you might risk losing some of them. So that is one that's not usually as intuitive for people. Average number of children versus child mortality. So again, we have good data for that one. This is child mortality rate, and you can see in the air where it's highest, the countries tend to have more children also. So there's, again, good data behind this idea. And there's still more factors that decrease fertility rates. So I just decided to throw all these ones out there. So greater availability of reliable birth control. And you can see actually that in the graph down here, in that if you have more availability of birth control, people will have fewer children. Greater availability of legal abortions, and then just changes in religious beliefs, traditions, cultural norms, etc., away from encouraging large families. So I'm from a Catholic family, and the Catholic Church has traditionally encouraged like no birth control, big families. And I have friends who are Catholic who are like part of 8 children, 12 children. I'm one of 4, but was more of a generational thing with my family. But as we move away from those sorts of things, people realize that, yeah, you shouldn't need to have really huge families. All right, so population growth versus total fertility rate. This just divides it into sectors, and that if these countries tend to have more babies and their populations are growing, these nations are still growing, and we'll talk about why, even though they're having fewer babies. This one, fewer babies and shrinking. And again, notice the countries in Europe versus the countries in Africa. The key for the colors is not in here, but you can kind of figure it out. And then there's only one country over here where they're having more babies, but their population's still shrinking. And if you know anything about Syria, it's not, what's going on there it's not ideal. Okay, so this one's a little graphic, and notice early on, and we'll go back to the beginning in a moment, but this is projecting, this is past, looking at total fertility rates. And as the countries turn blue, it means that the fertility rates are decreasing. And you can see that by the time as we start projecting into the future, that we're looking at the fertility rates across the entire world to be decreasing down towards just the replacement rate or even below replacement rate. I just want to let it go back to 1950 for a second to let it show you just how high it was across the world. Look at how many nations were in red or the yellows starting out. So as a world, we already have come down a lot, but we still have a ways to go to get to that just replacement level so that our world population stabilizes rather than keeps growing. So if you're looking at the health of a nation, and this is going to affect how many children you have and how much your population grows, one of them is going to be that infant mortality rate. In places where it's very low, people tend to have fewer children. And if you look at it, United States, we're kind of a little bit middle of the board on this one. We're in the low category, we have low infant mortality rate, but there are a lot of nations, particularly look at Canada, Australia, and nearly all of Europe that have lower infant mortality rates than we do. So I find that a little distressing that we're not the leader in this category or in the head of the pack. The other one is average life expectancy. And again, notice that the United States is not top of the list in this one either, even though we're a highly developed nation. So high life expectancy also just, so the 2 measures of a good life is what's happening at the beginning, a low infant mortality rate, and what's happening at the end, how long do your people live? And as far as across the world, the highest life expectancy is actually the Japanese. So, but if you look at, again, Canada, Australia, most of Europe actually outdoes us also in life expectancy. So, and some people find this distressing also because we pay the most for our healthcare, but we have poorer health outcomes than a lot of countries where their healthcare costs are much lower than ours. Okay, so looking at trends over time. Ooh, and I just decided to throw this one all out at you too. All right, so in the last, few decades, et cetera, death rates have decreased substantially, or in the last 100 years, sorry. My little picture's in the way there. And what's the reasons for that? We've had a couple revolutions. Improved agriculture, the green revolution has been huge. The industrial revolution also really decreased birth rates or the need to have lots of children. But the other thing was the advent of modern medicine. So lowering things like the infant mortality rate. So birth rates have also decreased, but not as fast as death rates. And so we're going to get at something called the demographic transition soon. as we look at how these things play out over time. So the difference in between birth rates and death rates is what leads to explosive exponential population growth. So here's the demographic transition model. Early on in the pre-industrial stage, you have high birth rates and high death rates. So people aren't living very long. A lot of your children might die in infancy. We don't have modern medicine. We don't have good agriculture. And so we have a lot, birth rates and death rates are high, and your population is fairly stable because birth rates and death rates are pretty much matching each other. Then we hit the transitional stage. And in the transitional stage, look at the death rates. They really drop off. So things like the advent of medicines, a good food supply, industrialization. Your population, though, people still keep having lots of children. It takes a while for the culture to change, for people to realize that they don't need to keep having so many children. So this lower line represents population. So early on in the pre-industrial stage, it's low because you have high birth rates and high death rates. As soon as you hit the transitional stage, you go into explosive population growth. As you near the end of the transitional stage, birth rates do start to come down and start to get closer to death rates. But as long as this line is above this line, you're still gonna have a growing population. So this is still increasing. As we hit stage 3, the industrial stage, so birth rates keep dropping, and again, now we're starting to reach stabilization. We're not quite there yet because, again, our birth rate is still above our death rate, but our population growth rate is slowing. As a planet, this is pretty much where we're at right now, probably at the beginning of this. Post-industrial stage, then there's a couple different end results. One is that now we have birth rates and death rates are both very low. So we have low numbers of infants dying, low death rate overall, but also our birth rates have dropped to match that. So you have population stabilization. And again, it shows it oscillating because you never get it just perfect where you're going to have a completely stable population size, but it kind of oscillates around a stable size. But there's a second outcome that a lot of countries in Europe are starting to see, and also in Japan, is that you might actually get to the point where your birth rates drop below your death rates. And if that happens, then you get negative population growth. So your population will actually start to shrink. So this is not inevitable. This is just there's basically 2 outcomes for stage 4. One is stable population, one is a potentially shrinking population. So I just wanted to show you this one. This is a little bit more updated version of the demographic transition model. And notice there's 5 stages instead of 4. And at first this kind of confused me. And so I broke it down and compared it to the other one. And what they did was they broke up stage 2 in the model that I showed you into 2 different stages. So stage 2, stage 3, which then bumps that last one out to stage 5. And what they did is they broke it down to where death rates start dropping rapidly, but birth rates have not dropped at all. They separated that out from where birth rates are coming down, but they still aren't anywhere close to death rates. So just if you ever get one of these on an AP test or you see it out there, make sure you're studying the graph rather than just memorizing what stage 1 is or stage 2 is, etc. This down here shows you the population pyramid sizes for each of those. So we're going to go into those next, and you've already had some experience with those in class. So it kind of shows you for each one of these, what are they going to look like. Right. And then the other thing that's really interesting to me is that over time, we talk about countries in Europe versus countries in Africa, but that's just a snapshot in time. All countries have to go through the demographic transition. All countries start out with that high birth rate, high death rate thing. And then over time, as they industrialize, et cetera, they go through the transition. And so what's interesting is that some of these countries that went through it a while ago, it actually took them longer to get through that demographic transition than countries that have undergone it more recently. So this is just an interesting graph. It says, how long did it take fertility to fall from more than 6 children per woman to fewer than 3 children per woman? And for some countries, it took longer than others. And we were actually on kind of the long side for that one. In the years where I was born in the 1960s, the average children per woman was 3.5. And my parents had 4. So they were kind of right in there with the average. And I'm not that old, right? So anyway, here are just 5 different countries looking at their demographic transition. And you can see the various lines for birth rate and death rate, and then the total population rate. So the demographic transition is going to look a little bit different for every single country that you examine, but they all have in general the same characteristics. And the point at which you get the biggest explosive growth is when there's that biggest difference between birth rate and death rate. So for Germany, it's there. For Sweden, around the same time. For Chile, happens a little bit later, right in here. or I think it's Mauritius. I'm not sure how you pronounce that one. And then China, you have it in there also. So again, different countries taking different amounts of time to go through the transition, but also different countries happening in different decades. All right, so into the pyramids. You've already kind of studied these in class, but when you have a super wide base, you're going to have a rapidly growing population. That's because all of these people are pre-reproductive. As soon as they hit reproductive, they're going to start having children. So this is almost inevitable if you have a population of this size, that you're going to have a rapidly growing population. If it's just moderate, you're still going to be growing, just not at the same rate. So you see some examples underneath each of these, and we'll be looking at more in our case studies. So if you have zero population growth, you're going to have a very straight-sided pyramid. And the reason is that you're basically, the reproductive group is just replacing themselves in the pre-reproductive group. So you're not expanding the space at all. And then the final option is that you have a negative base. This is the inverted pyramid, where if you are narrower down here, it means that the people in the reproductive age groups are having fewer children. They're not replacing themselves. So there's fewer people down here than here. And if this trend continues, your population can shrink quite a bit. And if we look at developing nations versus developing nations tend to have wide bases. They haven't gone through that demographic transition yet. Developed nations tend to have those straight-sided things. And so over time, this kind of shows a difference between, say, 1985 and then to 2025. And if you have a wide base, as this all moves up into reproductive years, the whole population increases. And then they keep having children, and it starts pushing it out further and further, and you get more and more population growth. So just a comparison between two countries that have one rapidly growing and then the other one that is at the shrinking stage. India is a developing nation, so it was very wide based. This is the year 2000, but by the year 2050, they're going to have a lot more people. So again, look at, there's a lot more purple area. There's a lot more filled in kind of in these areas. But by 2050, they're expected to be fairly stable, fairly straight-sided. So they'll start to reach stabilization beyond 2050 and beyond. Japan started out with a super wide base. And this was, I'm trying to see the year there, 1950, but by 2007, they'd gone slightly negative. And by 2050, they're projected to be strongly negative with their population growth. So, and this is rather concerning to the Japanese, because if your population shrinks too rapidly, you can have issues trying to support your elderly population because there's not enough young people to do that. So where are we headed? This is population growth rate, K, over time as a percent. And you can see, and there's some bumps in there, and you can pause the video and read about why that happened. But this is where this graph was made around 2015. And you can see that population growth rates are projected to keep decreasing over time to the year 2100, so that our population as a planet will stabilize. And then what does that look like on a population growth curve? It's the logistic growth. So you can see that it's been going up exponentially. This is us in 2000. We've kind of hit that inflection point, and we are now, this is the exponential part. We're now entering the logistic stage of growth. And looking again, and where exactly we top out, estimates range from 9-point-something billion to 11 billion. So no one really knows where we're going to be topping out. This one projects all the way out to 2150. And just also note that most of that growth is going to be happening in the less developed nations compared to the developed nations, because again, they're the ones that haven't gone all the way through the demographic transition yet. All right, so a few more graphs just to kind of hammer home the points, because there's all different ways to look at these things. This is world population growth. Again, this is the growth rate showing it dropping off. And this kind of goes back further in time, showing when our population growth rate really took off. And then projections from the UN from the most recent report that they released. They're looking at hitting 10 billion people in the year 2056. But look at the time it takes to go from 8 billion to 9 billion to 10 billions, getting progressively longer in time. So again, that look that we are starting to level out in our growth. And then just a few more graphs, sorry. And then, so why are we projected to still keep growing until the year 2100 when all of our growth rates are kind of really dropping off and in a lot of these countries are starting to level off? There's something called population momentum. So if you notice here, we're still going to be adding people as of the year 2100. We haven't hit zero growth at that, because this is a graph of population growth. What is population momentum? It's due to time lag, right? So if everyone today just started having 2 children, That's not going to help that if 20 years ago people were having 5 children or 4 children, because the people from 20 years ago are now going to be the ones starting to have children of their own. So there's a time lag between when you have the children and when those children start to have children. So populations continue to grow even after the fertility rate has decreased to replacement level, because of the large number of young people you might have in the population that will grow up. And if they all grow up and have just 2 children, there's still a lot of them because their parents probably had more than 2 children, if that makes sense. So, so even as fertility drops off, your population can still bulge for quite a while until basically the whole thing works its way through the population pyramid. So this is just another graph from our World in Data. It's not the best quality graph, but it just says it keeps the number of global births high even after the number of children per woman has had. So again, you can see the leveling is starting to happen, but this is replacement level here, but population will still keep growing until those people phase through their reproductive years, the children of the people who had a lot more than 2 children. It's starting to not make sense. All right, this is the final slide. The demography of the world population. I love this. I think it's beautiful, but it's actually shows kind of scary too, because it shows just how big we're going to get. So this was the 1950 population, very wide base. And you can see over time, here we are in close to 2018, we're starting to get level sided. Some of these bumps can be due to things like the baby boomers and wars that can have a big effect on population size. Notice by year 2100, we see a very straight-sided pyramid, which shows stable population. However, if you look at the size of how many people this represents, the numbers of people across the top of the graph, it's really pretty huge. So we're going to have a lot more people on the planet because you have to count all the people underneath the umbrella of the pyramid as your population. So it's going to be a lot bigger than it is today, but it does look like we're going to stabilize by the end of the century. So that actually ends our lecture for today. We'll see you back for lecture part 2.